cover the different technology building blocks that we use to develop the technology, some of the limits of the technology application, and then end with some conclusions. So compact compression systems were developed as an answer or as an improvement to conventional compression packages, which are typically used in offshore applications where you have the rotating equipment and the process equipment packaged in the multi-deck systems following some guidelines and rules that were developed several decades away. So by using different technology building blocks, we can substitute some of the conventional equipment by new technologies that are available, and which allow a reduction in the size and the weight of the system, and then sometimes an improvement in the performance of the system. Some of these building blocks are the integrated rotating separator, which does the function of a gravity-based scrubber. Also, if you use a high-speed motor to directly drive a compressor, you can remove the need for a gearbox. Of course, the high-speed motor, because it operates above the frequency of the grid, you need to include a variable frequency drive. But that also provides you with the capability of operating at variable frequency. When you eliminate the gearbox by using the high-speed motor, and you're eliminating pretty much the largest consumer of oil on the train. So one step further, you can use magnetic bearings in order to eliminate the oil from the plant. In addition to that, you can also eliminate the dry gas seal system if you use what we call the hermetically sealed motor compressor system, in which a pressure containing casing is installed around the motor, the magnetic bearings, and the compressor. And now you have no penetrations of the casing by the shafts, so you have a sealless system. Of course, for this, you need to have a way to take the electrical signals and control and power to the magnetic bearings in the motor, so you have to use electrical penetrators. So by using these different building blocks, we actually can go into more compact systems. The systems have been developed always thinking with the objective of improving the reliability, availability of the system. In most cases, you have an enhanced performance, so you can make a better use of the energy that is available at the plant. Also, because these systems are more compact, in general, you would have an overall reduction in the size of not only the equipment, but of the full module that encompasses the compression system. And if you do a life cycle cost analysis, you will see that most of these solutions, in the end, because you have less maintenance, you're removing a lot of components from the system, you're simplifying the system, you can actually have a lower total life cycle cost. Even in some occasions, the CapEx or capital expenditure at the beginning of the project may be a little bit higher. But overall, when you use the energy more efficiently and you reduce the number of stops related to oil bearing systems or to dry gas seal systems, you can actually get a lower life cycle cost if you include maintenance and operation.